Trigonometry review, looking at unknown sides and the trig ratios. So right angle triangle trigonometry, I'll look at the ratios, sine, cos and tan, labeling the sides and using the ratios to solve for unknown sides. Trigonometry relies on the fact that in a pair of similar triangles, the relationship between sides is going to be the same. And a pair of right-angled triangles will be similar if one particular angle is equal in each. So, because that of course will mean that the third triangle is equal as well. And so trigonometry is using the characteristics of similar triangles. If you want to know more about it, check out one of the optional videos, please. When we label the sides of our triangles, this only works for right-angled triangles, we already know the hypotenuse, that is opposite the right angle. So this is our hypotenuse on this is our hypotenuse here. The other two sides get labelled as the opposite and the adjacent, and that depends on which angle is the one that we are using to solve the problem. Sometimes it will be just marked with theta, sometimes it will be marked with the value, the size of the angle. Opposite that angle is the opposite side, and next to that angle is the adjacent side. So this one's opposite, this one's adjacent. Excuse me. So we label them the opposite, the hypotenuse, and the adjacent. And you can see that if I do opposite divided by adjacent, the relationship, the ratio between the opposite and adjacent sides here, 3 divided by 4 is 75%. If I did the same here, opposite divided by adjacent, you'll see that 6 divided by 8 is still 75%. We've got the same ratio between these pairs of matching sides, and this can be used to solve problems. Whatever this angle is, that's one particular angle. We know those two are going to be the same once we've seen that these are similar triangles because of the trig properties. So, each of these pairs, opposite and adjacent, or opposite and hypotenuse, or adjacent and hypotenuse, can be compared. And in any pair of similar triangles, they'll have the same relationship, the same ratio. Rather than keep repeating, use the ratio of opposite over adjacent, they get given names. There's actually some logic to them, we'll talk about them later. The sine ratio is just the name for doing opposite over hypotenuse. And we're saying the sine relationship between for a particular angle is opposite divided by hypotenuse. Cosine or cos of the angle is adjacent over hypotenuse. It's just quicker than saying the ratio that is adjacent of the angle over hypotenuse. And the tangent ratio, or tan, of the angle is opposite over adjacent. So that's 3 possible combinations of sides that we've got there, 3 different angles that have been given 3 different names. So the sine ratio of opposite over adjacent here is 3 over 4. The cos ratio here of adjacent over hypotenuse is 8 over 10, or 4 over 5. So each of these can be used to solve problems. You can, of course, remember SOHCAHTOA if you want, or some old hags can't always hide their old age, but what you must write is these 3 ratios. The particular one that you choose to use to solve your problem, this is just a mnemonic, a memory aid. So we need to be able to solve for unknown sides. And the steps for any trig problem are as follows. You label the sides. So here, this is my angle. I usually choose to label only the sides that have something on them. This side has nothing on it. It won't be involved in my calculations. I don't want it. I've got hypotenuse and adjacent. Based on which sides you have, you choose and write the relevant ratio. I've got adjacent and hypotenuse. The ratio that uses those is cos, so I write cos theta equals adjacent over hypotenuse. You must write the ratio in full. And after this, there will be another 3 lines of working. So there's 4 steps, 4 lines of working for every single trig problem in right-angled trig. Substitute in the values that you know. So that is cos of 27 degrees equals our unknown x over 11. And my 4th step is to rearrange and solve. Now, if I typed cos of 27 degrees into my calculator, I would get a number. It would be a decimal or a fraction. At this point, in your calculator is stored what the cos ratio should be for a 27 degree angle. And if in fact I just do cos 27, which I don't have to do in solving this, I'd discover that cos of 27 degrees has to be 0.891, etc. So something divided by 11 is this. So all I'm doing is I'm pulling up the appropriate ratio value from the calculator, and I'll use that to solve. Now just a thing to mention, your calculator has to be in degrees. DEG, or D. That's because we can measure angles in degrees or radians, and you do need to tell your calculator which we're doing, otherwise it will be basing its calculations on wrong information. Now that was just as an aside, that we can get this value from our calculator. We don't actually need to, because we can rearrange here to find x. I want x on its own. I have x divided by 11. I'm going to multiply both sides by 11 to get x on its own. 11 times cos 27 degrees equals x. You don't need to write the times. And so x equals, and we'll just do 11 times cos 27 degrees. X equals 9.8, and I'm measuring in centimetres. So 4 lines of working, 4 steps to solve these problems. Another unknown side question. We follow our 4 steps, which I'll try to keep on screen there. Label the sides that have anything on them. Here's my angle. I've got opposite and I've got hypotenuse. Choose and write the ratio. The ratio that uses opposite and hypotenuse is sine. Sine of the angle equals opposite over hypotenuse. Don't forget to write theta. Substitute in your values. Sine, don't forget to say it's 33 degrees, equals 21 over my unknown. Now rearranging to solve this, this is where you've got an unknown on the bottom of a fraction. You need to get x on its own, and you cannot leave x on the bottom there. To get rid of this divide by x, we would of course multiply by x on both sides. X times sine of 33 degrees is 21, and the reason I'm putting this line in pink is that that's actually an optional line of working, because I still don't have x on its own. I've got x times sine of 33 degrees. I want to get x on its own. I'm going to divide both sides by sine of 33. I'll be left with x equals 21 divided by sine of 33 degrees. Now, you are welcome to show this line of working if it helps you remember how to rearrange. You are welcome to go, look, I'm going to multiply by x and divide by sine 33 and just skip straight to this line here. So this is an optional line. And then 21 divided by sine of 33 degrees, and I've got 38.6 and we're in meters. So your steps that you have to use: label your sides, choose and write your full ratio, substitute in the known values, and rearrange and solve.